Hello and welcome to this webinar. Thank you all for joining us today. My name is Stuart Scott, I'm from Cloud Academy, and today we should be discussing how to efficiently manage and optimize costs for your containerized workloads running on Amazon ECS, the Elastic Container Service. Now, purchasing compute capacity can be a bit of a minefield. There's such a wide scope and array of different EC2 instances out there for every type of workload. And then when you start to couple this with the different purchasing options available, it can be a bit difficult to know where to start and how to optimize your costs. So hopefully today, this webinar will help with some of the confusion and make things a little clearer for you. Now, on the panel with me here today, I have Tomer Hadassi, the Solutions Architect Team Lead at Spot. So welcome to the webinar, Tomer.
Thank you, Stuart. It's really great to be here.
It's a pleasure. It's great to have you with us today. So, as I say, I'm Stuart Scott, and I'm from Cloud Academy, and I'm the AWS Content and Security Lead. So let's take a quick look at our agenda before I hand the reins over to you. We'll start off by looking at ECS and Spot Instance Management. We'll then take a dive into container-driven scaling and how that operates. We'll then cover quickly exactly what EC2 Spot instances are. Then we'll have a review of a product by Spot called Ocean, followed by a demonstration as well, which will involve that product on how to optimize your costs around ECS. And then finally, we'll have a Q&A session. Now, I'm looking forward to hearing and seeing what you have for us today, Tomer. But before I hand it over to you, I just want to let everyone know that if you have any questions throughout the webinar, then please post them in the chat window and we'll try to answer as many as we go. Alternatively, we also have a Q&A session at the end, like I mentioned, to try and answer as many of them as we can. Okay, so without further ado, I'll hand it over to yourself, Tomer.
Perfect. Thank you very much, Stuart. I really do want to reiterate what Stuart just said. Please ask questions, be engaged. We're more than happy to answer them as we go and kind of, keep them in context. But if not, we'll address everything at the end as well. So, as Stuart has mentioned, I'm Tomer. I'm from Spot.io. I lead the solution architecture organization here. And we here at Spot are trying to lead the way through CloudOps. What we see CloudOps to be is really best practices, processes, and tools applied to successfully deploying and operating modern applications in the cloud. We see that running as two separate pillars. The first one is DevOps, which is the one we're focusing a bit more on today, which is really the entire world of software and infrastructure build and deployment. So this is what your engineers are doing when they want to deploy software into the field. They use tools like Jenkins, like GitLab. They use monitoring tools like Datadog, like New Relic. And they use, obviously, the cloud providers to manage the infrastructure. And the other one is FinOps, so the entire world of cost management and continuous cloud infrastructure optimization. Essentially, the idea of you're continuously integrating, you're continuously deploying, you should also continuously optimize. And this is really what.
Sorry, just to interrupt there. I'm just wanted to say that I'm seeing more and more interest in the whole FinOps space as well across the industry. It's becoming more and more apparent of how important that element is.
Yeah, as small organizations are kind of adopting the cloud, I do have to say, the cloud is a phenomenal thing. We should all really be thankful it exists. It helps businesses and technologies really adapt and move much faster.
Sure.
The problem is that if it's not managed appropriately, it can actually come down to be more expensive than your own data centers and your own managed infrastructure. But if it is managed efficiently, it's necessarily going to be faster, smarter, more efficient, and cheaper than running your own infrastructure. But you just have to be a bit on top of it and perhaps leverage a few tools out there that help you achieve that. The one and the perspective we believe that is slightly missing for many organizations today is the entire idea of continuous optimization. So especially when you use containers, you continuously integrate and you continuously deliver software. You're constantly changing it. I would say I've seen organizations probably deploying software to production 20, 30 times a day, even. When we used to develop in waterfall methodologies, we used to do that perhaps once every 3, 6, 12 months. Then we moved into Agile, and we just became much faster in deploying, in developing, and running the regression testings automatically. And we can get our software into production many times on a daily basis. At the same time, what I haven't seen adapting is the idea of optimizing the infrastructure continuously as well. We see that infrastructure optimizations essentially happen once every quarter, every 6 months, or every year even. You go through this large exercise, analyzing all your infrastructure, analyzing all your applications, trying to find different methods of optimizing. Many times that comes down to buying reservations and savings plans. Sometimes you're adopting some more sophisticated models. But the problem is that the very next day your applications are starting to change again. And perhaps a lot of these changes are minor. So over the next day, week, or month, the optimization you've done is still very effective. But over a few more weeks or a few more months, those incremental changes together become a really big one. And you have to go and optimize infrastructure again. So we truly believe that infrastructure should be continuously and dynamically optimized and be application driven. So the entire notion of application driven infrastructure. A bit more about us. We are deployed worldwide in over 50 countries, and we work with enterprises and small, medium businesses to help them understand and adopt continuous optimization models. Today, we do want to focus on ECS specifically and containerized optimization and how we do that using spot instances and managing the entire ECS infrastructure. So first of all, I want to talk a bit about the ECS itself. So really, every container orchestrator is split into two pieces. The first one is the control plane. So control plane manages all kind of the scheduling of containers, making sure they're sitting on the right, in ECS's case, container instances, they're load balanced appropriately, they're auto-scaling appropriately. And then you have, on the other side, your data plane. So data plane is really where the agents sit, is where all your workers are, is where your own applications and microservices are scheduled into. And I think an important thing to understand here, and that really is the core to a lot of the issues we're going to discuss today, is that, yes, ECS has been built by AWS, but it's been following traditional container architectures, which have initially been built to support data centers. So really, all the data plane didn't require much management in the early days because it was simply physical servers or VMs, and you kind of had what you had because you have to do a hardware refresh if you need more capacity. So you're generally over-provisioned in a data center because you have to account for maximum utilizations, not for minimum. And because of that, container orchestrators do a great job managing the applications distribution, but not the data plane itself. So they don't do a really good job, or they almost don't do any job in managing the underlying instances and making sure the right instances are available at the right time, which is, again, extremely native to the cloud, where you have utility billing and you pay for what you use. You want to make sure that your instances are as tightly coupled with your application as possible. So what that creates is really two separate layers of scaling. On the top layer, you have your tasks and your microservices. I've seen environments that can run in a single cluster, 2, 3, 4, 500 microservices, each one of them running in replications of, let's say, 2 to 40. And because of that, you actually have hundreds of different scaling behaviors depending on the different applications that you're running and the metrics that feed them. Then underneath, you have your infrastructure as a service, so your cloud provider. In this case, we're talking about ECS, so AWS, obviously. And you're using scaling policies that are trying to analyze what's going on in everything on average and scale out infrastructure that is pretty homogeneous and identical to itself. It's pretty hard to set it up to be more sophisticated and more native to the containers. So we'll have to deal with those two layers and make sure that they're as tightly coupled as possible to own our costs. Now, the top layer scaling is the ECS services. that they're auto-scaling. Every service manages tasks underneath. They check their metrics using CloudWatch every 30 seconds or so. And when they hit a certain threshold, they will update the number of tasks either up or down and cool down before scaling again. Now, that's a single microservice that is an ECS service, and you can have hundreds of those checking metrics and changing their behavior throughout the day, which really can mean you might have a change almost every minute. Now, that really presents a problem. On the one hand, we want to make sure we're meeting application demands. So we have all these microservices that are constantly changing, and we want to make sure that they always have infrastructure available. The easy way to do that, just behave like a data center. Throw a ton of capacity at them, make sure there's always more capacity than you need available, and you're accounting for bursts. The issue with that is that, again, you're paying per second for what you use. So really, you should aspire to minimize idle resources when you run in the cloud. Ideally, these resources should be shut off, and you shouldn't be built for them if you're not using them. Now, we see 3 different layers to tackle this problem. The first one is the instance sizing. So we want to make sure we use the right instance at the right time in terms of how many resources it has available. Is it a high memory machine? Is it a high CPU machine? Does it have GPUs in it? Is it extra large and has 4 vCPUs and 8 gigs of memory, or is it 18 extra large and has like 96 vCPUs and half a terabyte of memory? We want to make sure we use the right instance at the right time based on how tasks are coming in. Then we also want to make sure we use the right instance lifecycle. AWS today offers your on-demand machines, which you pay as you go, the full price at the market rate. You have commitment models through different types of RIs and savings plans that will give you 30 to 60% off in exchange for committing for 1 to 3 years upfront, or no upfront, but committing to the usage. And lastly, which we want to talk about today, we have spot instances, which are the cloud providers' excess capacity at a 70 to 90% discount. We'll talk about some of their challenges later. And we want to make sure to use the right instance lifecycle and the right billing model at the right time. And lastly, we want to make sure that the services and the tasks they create ask for a correct amount of resources. So if all of your developers are constantly rounding up how many resources their microservices need, that can add up to 20, 30, 40% more resource requests than what you're actually utilizing, which translates to 30, 40% higher bill than what you actually need to pay for what you're using. Making sure you tackle your spend and your optimizations in all those 3 layers will guarantee that the cloud becomes more cost-effective, more flexible, and more efficient than really anything else out there, and will help you really tackle your cost problems. The way we want to do that, and the way we strive to do it really, is going with a different approach than thinking about it as 2 separate layers of auto-scaling. We want to do container-driven scaling. We want you to stop thinking about instances and about infrastructure as a whole, and keep focusing on your services, on what differentiates you as a business and the applications you're building and selling. Well, something automatic and dynamic continuously optimizes infrastructure, making sure all the resources are available for you when you need them, while making sure that no excess resources are there. So really, we want containers to be first-class citizens here. So we want the instance size, its type, and its pricing model to be based on the task or container and its specifications, while we're honoring all the ECS built-in constraints, labels, network, and storage requirements. It means that if we have a small task, we will launch a medium instance. And then if we get a larger task or a microservice coming in, we'll know to spin up a 2 extra large. And if we have 2 small tasks coming in together, we might spin up a large or an extra large machine to make sure they are as bin packed and as efficiently utilized as well. More than that, we want to be really driven by what the application needs. So if suddenly you have a task that requires GPUs because your data scientists have decided they have containerized their models, we want them to be able to freely push that into your clusters while reading from the task that it requests a GPU and launching an instance appropriately. And lastly, not everything can successfully work with ephemeral servers or spot instances. Some applications will really not handle well an interruption, even in microservices architecture. So again, they should demand to be running on demand, and the orchestrator should respect that based on the task definitions. So really what we've built is Ocean, which is a container orchestrator data plane management. Ocean takes over all your container instances or worker nodes in Kubernetes. We support all types of container orchestrators, from various versions of Kubernetes to Docker Swarm to ECS to Rancher to Nomad to Mesos and many others. And we take over the management of all the data plane. So all the worker nodes, again, this is where your spend is. AWS, if I remember correctly, allows you to spin up ECS masters or the clusters themselves for free, and you are getting charged on all the underlying workers. For EKS, you're paying, I think, about $100 a month for the control plane. The data plane can essentially cost an infinite amount, depending on your workloads. What Ocean achieves us is a serverless or basically a nodeless experience in Kubernetes. And what does that really mean to you? It means you're not managing any of your underlying infrastructure. Again, everything is driven by your containers and by their needs and dynamically changes. It means you're scaling by request on real-time requirements. That means your cluster might scale up and down every few minutes based on how your microservices are behaving, because again, there are hundreds of them and changes in the cluster happen regularly. Because we're in the cloud, we want to have utility billing, so you only pay for what you use. We eliminate as much waste as possible and prevent excess reservations that are unnecessary. We want to be able to scale to zero. Obviously, your production environments probably never will, but your non-production environments should be able to do that. If no one's working on them at night, there's no reason for you to keep paying for them. And we want to scale fast because we're staying so tightly coupled with our containers. Let's say they suddenly burst from 1,000 or 2,000 tasks up to 2,500 or 3,000. We want in a single event to see the sum of all these requests and take action and immediately scale up for all of them. We don't want to do this step scaling that will answer 150 tasks or anywhere between 100 to 200 tasks at a time, cool down for a few minutes and then do it again, because we want to be able to burst when necessary. I want to quickly talk about some of the numbers behind this. So you're probably asking yourself, what can I really achieve from that? Is this really worth all this overhead, all this headache? Why can't I just throw some capacity on it? So let's look at some numbers. We take a task that requires 6.5 gigabytes of memory and 1.5 vCPUs. And we try to use the same instance family at different sizes. At an M5 large, we can feed up a single task. It's going to use up 81.25% of our memory and 75% of our CPU. Because of that, there's no way we can put another task on it. So we're pretty much, from a unit cost perspective, paying the entire instance price. So about 9.6 cents an hour. That's the on-demand prices. Let's say we have two tasks and we go up one instance size. So we get twice the resources from the instance and we're paying exactly twice as much. And we're getting the same efficiency out of it. Again, 81.25 and 75 on the CPU. So the unit economics stay the same, 9.6 cents an hour. If we go up another instance size, suddenly we're getting twice as many resources, we're paying twice as much, but we're able to put there 2.5 times as many tasks on it. So suddenly, we're able to get to 98.44% utilization on the memory and 93.75% utilization on the vCPUs. And because of that, we're able to reduce the unit economics, or the cost per task per hour, to 7.7 cents, or about 20% cheaper. We're not talking here about any spot instances yet. We're not talking here about right-sizing the tasks. We're just talking about using flexible instance sizes that can be as efficiently being packed as possible. Now, again, when you have hundreds and thousands of tasks, you need to constantly make these calculations in the cluster to figure out what's the best makeup of instances to get the highest efficiency. Here's another example, going from a high memory to a high CPU machine. Sorry, vice versa, from a high CPU to a high memory one. Again, that pod takes up 81% of the CPU, of the memory, but it only uses up 45% of the CPU. And it pretty much wastes all that CPU unless you happen to have a task that's the reverse size of it. So again, about 17 cents an hour to run that task. We switch up to a high memory machine, understanding that the ratio of this task is closer to the M family. We get the same utilization on memory. We increase the instance cost because we're using the same vCPUs by only about 10%, and we're getting twice the utilization of CPU. So the cost per task per hour is down back to about 9.6 cents, and that's about 43% cheaper in this case. Now, Stuart, have we been getting any questions so far?
Not at the moment, no. Nothing's come in just yet.
Okay.
I think you're answering everyone's questions as you go.
So really, what we want to talk about next is what are EC2 spot instances? So as I mentioned, spot instances are the excess capacity in the cloud providers. The way we want to think about it, so we've spoken, or I mentioned in the beginning, how data centers are always ready for their maximum utilization. And really, the cloud providers have the same problem. Not only that they are constantly selling more cloud capacity and they are constantly getting more users into their platforms, they also need to be ready for a moment where almost all their users, all at once, require to get to their maximum capacity. More than that, an event like shelter in place that the world has been experiencing over the past few months makes so many more things move online. And we see companies in the gaming space, in the video conferencing space, doubling, tripling, quadrupling their infrastructure in a moment's notice, really. And the cloud providers commit to be able to always allow you to do that, which is amazing. But that means they have a lot of waste in their data centers too. They're paying the electricity, they're paying for the real estate, they bought this hardware, and they want to make something out of it. In AWS, they call these excess capacity spot instances, which are really the same EC2 instances you're familiar with already, at a 70 to 90% discount from the on-demand rate, pay as you go, no commitments. The one major caveat is that you get no SLA on them, and if a full paying customer wants that capacity, they will terminate your instances. However, every spot capacity pools happens at the intersection of an instance type and an availability zone inside a region. So a region like Northeast one or North Virginia has about 6 availability zones and 50 at least instance types, probably more, maybe even 200 or so across all shapes and sizes. That's about 1,200 different spot capacity pools. There's no way that all of them are going to run out at once, because normally if a major player like Epic Games or Netflix scales up because a lot of people are streaming at evening, they're probably using pretty cohesive instance groups and have a lot of reservations built up for them. So maybe suddenly the M4s will start, or the M5s will start getting really shaky. But if you're able to intelligently distribute across many different types, shapes, and sizes, there's always capacity available. You just need to be properly prepared for it. Which brings us to Ocean. As I mentioned earlier, Ocean by Spot is our containerized environments data plane manager that makes sure to optimize data planes across their instance sizes, their life cycles, and their container utilizations. So as I mentioned, obviously, fully container-driven auto-scaling. The instance type, shape, and family scales by the container needs. It simplifies operations because you're able to deploy more and move faster without worrying about infrastructure consistently. As I mentioned, it handles all the auto-scaling of infrastructure and the utilization of resources by constantly bean packing and choosing the right instances at the right time. allows you to bring your own control plane, ECS, EKS, GKE, AKS, and all of those are supported. And altogether, we've seen infrastructure costs reducing by up to 90%, but I would say no less than 60. So anywhere from 60 to 90% savings compared to how your clusters are running today. In addition to that, we'll give you deep and constant visibility into what's going on in the cluster and all the actions Ocean is taking, detailed cost showback and chargebacks in the cluster per service and task, as well as the sizing recommendations on how to best size your containers. And most importantly, everything we do integrates with infrastructure as a code and CI/CD by design. You can have things like Terraform, Ansible, CloudFormation, Spinnaker, APIs, and SDKs to communicate with Ocean and connect it to your ECS clusters in minutes, basically. So from here, I want to jump into a demo. So I want to quickly discuss basically the Spot platform. Really allows you to see everything that you're running, the usage over time, kind of obviously everything going on in the platform and in your environment as a whole. They obviously want to focus about Ocean and Ocean for ECS. Now, what Ocean does is, as I mentioned, help you manage those clusters and see them more clearly. What you can see here is a general overview of your usage. How many instances do you have and how many are registered into ECS? Their allocations in CPU and memory. How they're scaling over time. In this case, this cluster is configured to run 50% on demand and 50% on Spot. Though we do definitely have most of our customers end up with practically 100% Spot instances in production even because of how Ocean manages it. You can see it even in this case where it only has 4 instances, they're already leveraging a C5 large, an R5 large, a C5 large in a different availability zone, and another M5 large. This way, it allows you for a lot of distribution, and if AWS wants to claim one of those capacity pools, we don't have too much of our cluster in there, and we're not taking on too much risk. Everything you see here, again, completely driven by Ocean, completely driven by containers, completely driven by ECS. If I'll press any one of those instance IDs.
Just while that's loading, we've just had a question come in, just saying, when is there a plan for a feature for Spot to have a button to auto resize?
I'm sorry, could you repeat that?
Is there a plan for a feature for Spot to have a button to auto resize?
So Ocean does that automatically. So you don't really need a button. Ocean continuously essentially resizes your instances. If you're talking about the task right sizing, then yes, that is in the works to be automated as well. It's already available in beta for Kubernetes, where we basically capture your tasks or your containers as they're being deployed, and we reconfigure the requests based on how efficient they are.
Right, thank you.
Awesome. So again, we go to the container instances. If you press an instance ID, we get to see it immediately in the AWS console. You get to see all the text attached to it. All the description. You can see that its life cycle is Spot instances. More than that, we can go to the container instance configuration. We can see what's running in it, how it's allocated, which tasks make it up, and how efficient they're running. You can see from here all of our tasks. Go to any task, see which service it belongs to, go to the service itself, see how it's configured, how many tasks it has running, how they've been running over time, the task configurations via JSON. In cost, we get, as I mentioned, the detailed showback per service and the tasks underneath it and how they're costing us. Right sizing, again, we'll constantly analyze the tasks utilizations. So let's say you got an application, it requests about 4 vCPUs. In reality, we noticed that it spikes at 3.1 vCPUs at the maximum. We'll give you a recommendation to resize it in here, and the moment it gets redeployed through its service, we will bin pack the infrastructure accordingly. And here in the log, you can see how we take every action based on the services, how many are coming in, and the requests they make. Now, just so you can see that in live, let's go to the cluster. We're here in the ECS cluster inside the AWS Management Console. Let's see which services do we have here. So let's say we take the largest one, SFM Steven 6, requires 1 vCPU and 2 gigs of memory. Go into that. And we can update the configuration, increase the number of tasks from 4 to 10. Press next. Next again. If we wanted to have automatic scaling policies, we could have them to be configured in here, but right now I manually scaled it. We press next again on this and update the service. Successfully updated. And now we can see how this service is essentially launching more tasks. It has 4 running, it has a desired of 10, and it's soon going to be pending 6 of them. Let's give a few more moments. Again, in the meantime, if anyone has any questions or thoughts, please feel free to follow them.
We just had one come in just as you said that. It says, do we have an option in Spot to limit the number of pods per node?
So what we can do is, this is an ECS scheduling configuration at the end of the day. The ECS master or the Kubernetes deployment will decide how many go per node. But in Ocean, one of the nice things is it's really easy to configure things like that. So you can make sure that your nodes are no bigger than 16 vCPUs and no bigger than, let's say, 28 gigs of memory. And that will really, press next in here. We can see it here in the JSON that it removes from the whitelist any very large machines. And this can limit basically how many pods or tasks land on an instance. Otherwise, this is an orchestrator level configuration. So you can make sure in, let's say in Kubernetes, that during the bootstrap, it limits the maximum pod count in a node to 20 or 30. But it's the Kubernetes scheduler that's eventually going to bin pack them as much as it can. So we can't actually control it from the instance configuration, but we can limit the instance size to respond to that accordingly.
Okay. We just had another question coming. Are you looking at nodeless Kubernetes technology to avoid bin packing inefficiencies?
Are we looking at what? Sorry?
Nodeless Kubernetes technology.
So we are basically the nodeless Kubernetes technology. We enable you to. So I think something really important to mention, to talk about when we talk about serverless or nodeless, is that there are always servers. They're never going anywhere. When you run a Lambda or when you run a managed database or when you run anything like that, there's always servers there at the end. The question is, are you managing them or are they just available for you to run your workload as you wish? And we are able to achieve that with Ocean, that yes, there are still EC2s underneath your cluster, but the experience you as an operator and your developers have is completely nodeless. We make sure you see everything that's going on. You have complete visibility and control over it if you'd like. But really, it is a nodeless experience. All nodes are being launched, or all container instances are being launched based on the application requests in terms of CPU, memory, any taints, tolerations, and limitations that they have on the container level. And then they register to the cluster, and you don't really need to do anything about it. So Ocean really enables you to work in a serverless way. We're not leveraging any external technologies like Fargate to achieve that. We achieve a pretty similar experience by managing the nodes for you. And just quickly, right in here, we can see that we had 4 tasks there earlier. So Steven 6 now has 6 pending tasks, each one of them requesting 1 vCPU and 2 gigs of memory. As I mentioned, the cluster runs 50% spot, 50% on demand. So we got a few larges, C's and M's, 1 spot, 1 on demand, another spot, and another on demand launched to handle that. In the meantime, in the ECS side, we can see that this is not refreshing. It does. Interesting.
The fun of live demos.
Yeah. But hey, the AWS side of things. That's interesting. So I think container instances are probably still launching. Yeah. So it's still finishing. They're still bootstrapping themselves, and then once they do, probably the tasks will start scheduling. But you can see basically that Ocean launched all of them, making sure that there's capacity available even before the tasks were fully ready to go. It basically saw the change in the service itself. Okay, now we're up to 4 pending ones. It is changing now. Okay. Some of them already got scheduled. We can see that now has 4 running and 4 pending. In a provisioning state, we can already see them inside Ocean. Can go into the task itself. See it's running an Nginx container. It's still in a pending state. I think it's a good opportunity to talk about something important. So while we have done a relatively big scaling event, obviously it's a very small sandbox cluster to handle all of those. What you would normally want to do, and what we do here, is do the automatic auto-scaling. That's right. So we want to make sure that our headroom is also automatic. It was set to manual on this cluster. My apologies. And it was set to be 0. Headroom really is available units of work in the cluster. So when we do have a smaller scaling event, the tasks or the containers can get instantaneously scheduled into that headroom or the buffer capacity. And then we do a scaling action to fill up that buffer. So let me update the headroom to be automatic. To probably scale a couple more machines for that to make sure there's always a buffer in that cluster. Well, this finishes scaling. If there are no questions coming up, so I do want to quickly show everyone what it means to connect an ECS cluster to Ocean. We'll create an Ocean cluster, which again is your data plane manager. We will join an existing ECS. We'll choose the region. In this case, I have one running in Oregon. Test. Choose an ECS cluster. We'll press next. What Ocean just did is basically fetch all the metadata or all the configurations you have on that ECS cluster today into Ocean, so you don't really have to configure it yourself. So we pulled in the VPC, the subnets to be running in, the images, the security groups, the instance profiles, the keepers, the user data, all the EC2 tags you have, your resource limits. So again, you're not thinking about nodes or instances. It's a serverless experience. You're just saying what's the maximum capacity you're willing to have. Say it's 2,000 and 10,000. And you can decide how you want to associate public IPs and affect the draining timeout. And that's pretty much it. We'll press next and create, and we're done. Ocean will start managing all your container instances from there. It will seamlessly read the requests from your services and tasks, and will handle all scaling. And we can see here in JSON all the configs. Now, I do really quickly want to talk about the machine types. So we saw that earlier. By default, we open up all types, shapes, and sizes because we will use them as we wish. And as we see the most efficiencies in the spot capacity pools. That being said, you can definitely limit those to only the ones you want to be running with, and kind of have a smaller list in here with older, and even the M6Gs that recently came out are already available. And we can change this to 6, this to 8, and then if we press next, we'll immediately see the more limited whitelist for the instance families I left on, and for anything that has up to 6 vCPUs and 8 gigs of memory in it. That really is as simple as that to connect your ECS cluster to Ocean and to stop managing infrastructure and immediately get everything you have running on demand, move over to spot instances, and everything leveraging your existing reservations will continue to leverage them as they are. So I mentioned how cheap spot instances are, but obviously, if you already purchased reservations, you want to make sure we utilize them and enjoy the benefits of the commitments you've already made.
So I've got a question here. How does Ocean collect ECS metrics for sizing recommendations, and which metrics does it collect?
Yeah, so Ocean connects to CloudWatch metrics really inside AWS. So it's all through the metadata of them. We look at the CPU, we look at the memory, and then we push out recommendations, still collecting data in this test cluster. And we push out the recommendations on how to right size it. It takes about 4 to 7 days of a running cluster to aggregate those metrics and data, because obviously we don't want to recommend you shrink down a task based on a few hours of running, because it might behave differently throughout the week. So we take a few days of a buffer.
Cool.
Okay, in the meantime, we can see how the task count for Steven 6 is already 8 are running and 2 are pending, and it's getting closer to its desired 10. We can see in Ocean how we have more instances running, again, maintaining the spot to on-demand ratio, getting those instances pretty well being packed on, especially on the CPU, which is, by the way, a lot more expensive than memory in itself. And we can see that reflected in the service on Ocean here as well. Yeah, I think that's the main gist of it for me. Happy to answer any other questions if anyone has them.
Yeah, thank you for that demonstration. I think we're kind of moving on to the Q&A now anyway, but we've had a couple of questions coming just towards the end of your demonstration there. We've got a question here. After setting up my ECS cluster in Ocean, how long does it take before recommendations are ready?
So it takes about 4 or 5 days of analyzing your existing services and pushing out a recommendation. Again, we want to make sure that we get a decent amount of time. We don't want to go too crazy and wait for weeks, but we also don't want to do it in hours. We need a good amount of data to kind of be confident, because at the end of the day, if your task is asking for 4 vCPUs and then over a 10-hour period, we see it never spikes up over 1.5, and we tell you limit it to 2. But really over a week period, it can spike to like 3.1. Then we want to be at that 3.1. We don't want to let it fail.
Sure.
So about 4 to 5 days.
Okay, and we have one more question here. Do you see a lot of companies making the shift from ECS to Kubernetes? If so, then why and when?
That's a great question. So yes, generally I do see a lot of companies feeling like they need to get on that Kubernetes wagon. It's kind of like the hottest new buzzword in the industry almost, and kind of if you're not doing Kubernetes, you're not cool. So we're seeing some of them do the shift, but to be fair, I see many of them choose very consciously not to. Kubernetes is a lot more robust, and if you want to build a large enterprise-ready container platform that can support a ton of edge cases and stateful environments, and all those limitations, this app not next to this app, and this we did that. Kubernetes has some more flexibility there and gets constantly updated. So I see these companies adopt Kubernetes. Also, you have all the open source versions where you can kind of modify security and make all the changes you want by yourself. I would say that if you have a smaller organization or like a startup with a couple dozens of developers around, ECS is more than robust enough to support your needs. And if you're already using it, it's not necessarily worth the effort of moving over to Kubernetes just yet.
Excellent, great. Thank you very much. I think that's all the questions that have come in and have been answered. Done a great job of attacking those as you've been going through your demonstration, so appreciate that. So that brings us to the end. Again, thank you all for joining us today, and a special thanks to you, Toma, for everything that you just covered in your slides and also your demonstration. Personally, I found it really interesting to hear how ECS and spot instances can be used to help drive cost optimization when used efficiently and effectively. And also, it was great to see that practical demonstration of Ocean as well. So thank you very much. If you'd like to learn more about Amazon ECS, then please feel free to take a look at our related content, including courses and hands-on labs here at cloudacademy.com. Just before I close up, Toma, do you have any final remarks?
I guess I have forgot to mention, my apologies, that Ocean also handles everything spot instances around containerized environments. So we do make sure to handle all the replacements, to gracefully drain them, to make sure that there's always capacity available. And even though we're using that excess capacity that AWS gives no SLA on, through our platform, we're able to achieve a 4.9 uptime and availability for your workloads. And as Stuart mentioned, if anyone has any questions or curiosity, you can always jump into Cloud Academy and learn a lot more about these technologies. And if you already are a user of them and you're interested in seeing how to leverage some of our capabilities, don't hesitate to reach out to me via LinkedIn or any other method you can find.
Great, thank you very much. And just as a final reminder to everyone, you'll receive the recording of this webinar via an email as soon as it's available in the next day or two. And don't forget to check out all of our other webinars, which you can find on our website at cloudacademy.com/webinars. So thank you very much to everyone, and goodbye.